HOD sir just joined right now. Good morning, sir. So we'll start within 5 minutes, sir.
Okay, ma, no problem.
Okay, sir.
Sir, good morning, sir.
Good morning, Hemant garu. Good morning.
Good morning, all the participants. We'll start the inauguration in 5 minutes. Good morning, sir. Principal, sir. We'll just start the session in 2 minutes, sir.
Please start immediately.
Okay, sir. The coordinators of today's FTP program, Dr. I. Hainlata garu, Dr. C.H. Madharao garu, and Mr. P. Srinivaslu garu. Our in charge HOD, Dr. P.H.S. Tejamurthy garu, our beloved HOD, Dr. T. Venkateswarao garu, our principal, Dr. K. Venkateswarao garu, our secretary, Dr. MBSV Prasad garu, Hariram Krishnaraj garu, and Malibab garu. A very good morning to one of you, all of you. I cordially invite you to the 1 week FTP on recent trends on communication, VLSI and embedded system. Before starting the inauguration, I would like to provoke this event with a prayer song. I cordially invite our second year students, Chaitanya and Sujata, to provoke us with prayer song.
Endu tushar tabada ya shupravasranita ya veena varadanda mandita kara ya shweta padmasana या ब्रह्माश्रुत शंकर प्रभृतिभिः देवैः सदा पूजिता सा मां पातु सरस्वती भगवती निशेषजाड्यापहा.
Thank you, students. Thank you so much. Now, I cordially invite the coordinator of today's program, Dr. I. Hemlata Madam, to give a report about this program. Madam.
Respected Chief Guest, Dr.D.Ranganadham garu, Deputy Director, Doordarshan, Kendra, Vijayawada. Dr. MBSV Prasad garu, Secretary, Sir CRR Educational Institutions. Sri Jasti Mallikarjunudu garu, Correspondent, Sir CRR College of Engineering. Sri K. Harirama Krishnam Raju garu, Member of Managing Committee and designated representative of Sir CRR College of Engineering. Dr. K. Venkateswarao garu, Principal, Sir CRR College of Engineering. Dr. T. Venkateswarao garu, HOD ECE and convener of this FDP. Dr. P.J.S. Tejamurthy garu, Professor, ECE Department, and HODs from various departments, my dear colleagues and participants from various colleges. A very fine morning to you all. I am Hemlata, working as an associate professor in ECE department and coordinator of this FDP program. Welcomes you to the inaugural of this FDP. Recent trends in communications, VLSI, and embedded systems. The main objective of this FDP is to enrich the knowledge of faculty, research scholars through interaction with the eminent personalities from industries and academics. This knowledge will improve the teaching learning process to the students and benefit the society. This FDP will be an eye-opening session for beginners and middle-level researchers. To our credit, total 109 candidates have registered from this program, out of which 35 participants are from our college and the remaining are from various institutions. From the state of Tamil Nadu, Telangana, and Andhra Pradesh. And another one important here, very proud of that, one participant registered from Ethiopia, Harmaya University from Ethiopia. One person is registered from that one also. From Telangana, Mallardi College of Engineering, and VNR and Vijaya IIT College. And from Tamil Nadu, KSR College of Engineering, and Satyabama Science and Technology, Chennai. And from Andhra Pradesh, the reputed college participants are registered from colleges. That is KHIT Guntur, Adi Shankaram, Sasi, Tadepalli, and SRKR, Vishnu College of Engineering. And one person registered from Agiripalli, IIIT, Nujibidu. And my sincere thanks to our management for their continuous encouragement and support even in this pandemic situation. My heartfelt thanks to today's chief guest for accepting our invitation and being with us on this auspicious day. I humbly thank our principal sir, HOD, and Tejumurthy sir for their constant support and cooperation. Also, my heartfelt thanks to all my colleagues for their continuous support. Thank you, one and all. Thank you, sir. Thank you.
Thank you, ma'am. Thank you so much. Now I request Dr. P.H.S. Tejumurthy Garu to convey his message on this occasion.
Dignitaries present in this meeting, my dear faculty members. So good morning, one and all. So we are very glad to announce you that this is the second FDP we are conducting. One already we have conducted with the AICTE sponsored FDP in 2019-20 on biomedical signal processing. And so now we are conducting in the communication VLSI and embedded system area, where exactly we require certain gaps to be fulfilled according to our syllabus. And for NBA purpose also, it is very, very essential. And the students are showing a lot of interest in VLSI and embedded system area. Almost 30% of the students, they are approaching us and give the particular courses in advances in VLSI and embedded system area. So for that we need to train up. This is very much essential. And I'm very happy and glad that there are participants from various other states, and even one is from the Ethiopia also. So we are very glad for this. And I congratulate the coordinators, Dr. I. Hemlata Madam and Dr. C.H. Madharov for taking all these efforts. And the last, I have to thank Dr. T. Venkateswara Garu, our beloved HOD, and Dr. K. Venkateswara Garu, our principal, and the management for their great support, without which we cannot conduct all these programs in this pandemic situation. Thank you very much, sir.
Thank you, sir. Thank you so much. Now, I take the privilege of inviting our beloved HOD and the convener of today's FDP program, Dr. T. Venkateswara Garu, to convey his message on this occasion. Sir. sir.
Thank you, Grishma. Today's chief guest, Dr. D. Ranganadham Garu, and our beloved principal, Dr. K. Venkateswara Garu, and our management secretary Garu, MBBS Prasad Garu, Mallikarjuna Garu, our correspondent sir, and Raju Garu, and my colleagues and my dear participants, a warm welcome to this RTCVS Recent Trends in Communications, VLSI, and Embedded Systems, FDB, and warm welcome to you all, and very good morning to you all. Yes, as our Professor Dr. Tejamurthy and Hemlata Garu said, yes, this is a very, very happiest occasion for the department, and we are conducting the second FDP. The students are very much interested towards to doing these projects or their research orientation papers and are all in these emerging areas. Now we have to set our ideas and the vitality in these key domains, VLSI and embedded systems. So not only teaching and assessing here, and also to improve their professionalism, and also to improve their research orientation towards these areas. So what are the various important developments in these years, recent years, should be known to the faculty, and also this definitely improve the education environment in the department and also in their departments, and to improve the academic performance, and all these FDPs will be very plays very vital role. In this, I have to say thanks to the management and also the key resource persons for this FDP from IIT Guwahati and NIT Warangal and our state JNT University JNT Kakinada, and various professors are here. They are ready to provide the important developments that was developed in these recent years. So it definitely prove fruitful for the faculty and the young researchers. So I'm very thankful to the management and our principal sir for giving this opportunity, and definitely we will do this type of programs in the future also, with the support of management and my dear colleagues and faculty members. Once again, I thank our today's chief guest Ranganadham Garu, in spite of his busy schedule, accepting our invitation, and also thank the participants. Thank you very much. Over to Grishma.
Thank you, sir. Thank you so much for your valuable message. Now I request our beloved principal, sir, Dr. K. Venkateswara Garu, to convey his message on this occasion. Sir.
Okay, thank you. Respected chief guest of the day, Dr. D. Ranganadham Garu, and guest of honor, Dr. MBSV Prasad Garu, Secretary CRR Institutions, and Jast Mallikarjuna Garu, Correspondent, CRR College of Engineering, and Sri K. Hariram Krishnaraj Garu, Member of Managing Committee and Designated Representative of CRR College of Engineering, and Dr. T. Venkateswara Garu, Head of the Department of ECE, and the coordinator of this entire program, Dr. Tejamurthy garu, and other.
సార్ మ్యూట్ అయింది సార్, వెంకటేశ్వర మ్యూట్ అయింది.
సార్ మ్యూట్.
ఇప్పుడే జస్ట్ మ్యూట్ అయిందండి, కంప్లీట్గా అయిందా?
జస్ట్ ఇప్పుడే అయిందండి, జస్ట్ ఇప్పుడే.
ఓకే అండి. A warm welcome to you all on this particular occasion of the conduction of the FDP, that is recent trends in communications, VLSI and embedded systems, a new area where the younger researchers can pursue their career. So this is the second FDP that is being conducted now by the Department of ECE. I am very happy to know this, and the inclination of the department to continue the same, and about its enthusiasm to conduct more and more FDPs, workshops, etc. As already mentioned by the coordinator Tejamurthy garu and the HOD Dr. T. Venkateswara, this will be an eye-opener for the beginners or research scholars or who are planning to pursue their research in these particular new areas. I congratulate the Department of Electronics and Communications Engineering for arranging such type of programs, and I hope that the faculty as well as the participating members from other institutions will utilize this particular session for their research activities and academic improvement. Thank you one and all. Thank you a lot.
Thank you, sir. Thank you so much.
Okay.
Now, I take the privilege of inviting Sri K. Harram Krishnaraj garu, Member of Management Committee and Designated Representative of CRR College of Engineering, to convey his message on this occasion. Sir.
Namaste one and all. I am happy I am to address this prestigious Zoom conference from our institute. First, I thankful to Dr. Sheikh Rafi Ahmad sir, Dr. P. Srihar Rao sir, Dr. N. Balaji sir, Dr. Mihir Narayana Mohani sir, madam, and Dr. Ranganadham sir, Dr. S. Sadanand Rashmi, and Sri Abhinav Karthik. I congratulate you, all our team and principal, our staff and coordinators of this meeting, this prestigious meeting. I hope, I pray God for all success of this meeting. Thank you for our HOD sir and principal sir, and all the participants are welcome to the prestigious seminar. So thank you one and all. Thank you.
Thank you, sir. Thank you, Raj garu. Now I cordially invite Dr. MBSV Prasad garu, Secretary CCR and Institutions, to address the gathering on this occasion, sir. We'll just wait for a second. Okay, sir. I think you may join later. Now, I take the privilege of inviting our today's chief guest, Dr.D.Ranganadham garu, Deputy Director, Doordarshan Kendra, Vijayawada. Before inviting our chief guest, I take the privilege of introducing our chief guest to the gathering, sir. Dr. Dharmana Ranganadham garu He belongs to 1988 batch Indian Engineering Services. He has graduated in Electronics and Telecommunication Engineering from Jawaharlal Nehru Technological University, Anantapur, Andhra Pradesh. He is also postgraduated in Digital Signal Processing from IIT Kanpur. He has awarded MBA degree in Finance from College of Commerce and Business Management from Osmania University, Hyderabad. And he did his PhD from Jadavpur University in the area of video coding using soft computing techniques. He has been working in Doordarshan since 1989, and he has the experience in Doordarshan studios and transmitters. Presently, he is working as Deputy Director General and Head of Doordarshan Kendra Vijayawada. He was awarded the Best Trainer for the year 2010 while working in Training Center at Bhubaneswar. His research interests are in the field of digital broadcasting and video coding. And also, Dr. D.Ranganadham Garu is life member of BES, IEI, IETE, and member of All India Management Association. Sir, here today we are very happy to have you here as a chief guest and also as a session person, sir. I request you to give an inaugural speech on this occasion, sir. Thank you, sir. Thank you very much. Dr. Ranganadham Garu.
Thank you, Amrita Garu, for your nice words.
Thank you, sir.
I thank the chair, management and faculty members for giving me this opportunity. Good afternoon, good morning to all of you, especially the people who have given me an opportunity. Dr. Mallikarjuna Garu, correspondent, Dr. M.V.S. Prasad Garu, secretary, Dr. K. Venkateswara, principal, Dr. T. Venkateswara, HOD, Dr. Tejas Murthy, and for you particularly, Hemlata Garu, who is always in touch with me, encouraging me for this. And overall, I thank your institute for giving me this opportunity. And good morning once again. The topic you have chosen, the recent trends in communication, VLS and embedded systems, are very apt for this faculty development program. We all know the tremendous progress has been achieved in the field of communication, VLSI and embedded systems in India over the last decade or so. One example is the broadcasting industry, where significant improvement is done in the area of coding, modulation, and transmission, along with the content creation. You all seen how the content has progressed in both in terms of quality and content. See, not only the broadcasting industry, look at the contribution of major organization, government organization in the research, like ISRO and DRDO, and some of the telecom industry, where tremendous progress has been achieved. These mega organizations have allowed the private participation in large scale in recent years, which resulted in phenomenal growth, which is fulfilling government thrust on Atmanirbhar Bharat. One of the example of Atmanirbhar Bharat is the mobile industry, where we have seen phenomenal progress in both hardware and software and in connectivity, and is now the second largest private sector, private investments in infrastructure of mobile industry is to the tune of 10 lakh crores. You can imagine how much contribution the mobile industry has given just because of private sector participation. Gone are the days where public sector alone contribute to the major sectors. Now, no worthwhile progress is achieved without private sector participation. This is the hard truth, and this government has recognized it. And that is why more and more scientific organizations also, the private participation is taken. If you look at ISRO and its growth, private sector participation is vital for its success. And in fact, some of the components manufactured in both the satellite manufacturing and launch vehicles, around 70 to 80% are coming from private sector. We have indigenously built satellites with 95% Indian components, and progress is very good in very launch vehicles like PSLV, GSLV, which is more difficult than the manufacturing. satellites, especially with their efforts with the Chandrayaan and Mars orbiter mission. If you look at the Mars orbiter mission, considering the fact that enormous distance involved in interplanetary mission projects present a demanding challenge. Developing and mastering of these technologies essential for these missions will open endless possibilities for space exploration. After leaving the orbiter, after leaving the Earth, the orbiter will have to endure the interplanetary space for 300 days before Mars capture. What is happening is to see significant participation from eminent institutions like IITs, NITs, and institutes like CRR in the private universities in building important components and nanosatellites. This kind of industry-institute partnership is vital for the students to enhance their confidence and the capabilities, thereby making them ready in the institute itself for future challenges. I'm sure CRR is doing a wonderful job in this direction. Last time when I came to CRR, you people have told me how you are contributing very minutely to this ISRO project also, and I hope you continue the same spirit. Similarly, the DRDO progress is phenomenal. The way they contributed to solutions for COVID pandemic, the way of building hospitals to developing drugs, hats off to their flexibility and capability, because it is not generally done by government organizations, but over the period of time, they have shown a lot of flexibility and capability. These organizations whose primary goal is developing, designing, and building, test firing all types of missiles for the security of the country in the area of surface-to-surface missiles, surface-to-air missiles, examples like Akash, Agni, and Prithvi and BrahMos. Their efforts have contributed immensely for Indian Atmanirbhar Bharat. In the broadcasting industry also, we have seen a sea change starting from a black and white TV and signal reception from terrestrial Yagi antenna to now more than 800 satellite channels, more than 10,000 MSOs, the cable operators in the cable industry, to now the OTT, over-the-top technologies, and streaming services. Broadcast industry has seen it all, and not stopping at that, with the entry of Amazon, Netflix, G5, etc. So the lots of shift is happening from traditional TV to nonlinear TV. In the pay TV segment also, migration from traditional TV to OTT services accelerated during this pandemic. Today, we are receiving 270 megabits per second SDI, digital signal. And for if you take HD, 1.4 gigabits per second HD signal through net. So that is a kind of progress made in terms of coding technology, which resulting in that in normal telephone signal, we are receiving such a high quality telephone signals. This is a result of the advancements in VLSI and embedded systems, wherein many of the compressions and playback is possible with these research in VLSI and embedded systems. High performance codecs with low complexity encoding and decoding are a must for future wireless systems because of the spectrum problems. We will see significant change in the way we communicate, machines communicate with 5G onset in the next year. This is all the result of significant progress in VLSI and embedded systems. Many of the coding algorithms which were implemented with hardware are now done with the software with a recent advance in processing power and low latency devices. Revenue growth in the mobile services will be buoyed to a degree by 5G adaptation, which will invite users deploy more advanced data capabilities and high-speed data networks. The recent advances in VLSI and embedded systems resulted in making mobile in India's largest technology platform in the human history. Because right now, Jio alone have around 40 crore subscribers. I thank the organizers in selecting such a vital topic to this workshop, and I'm sure many of the staff members and students will be benefited by this program. I thank once again for giving this opportunity. I wish you all the best and grand success. Thank you very much.
Thank you, sir. Thank you so much for your very motivational speech. And also, once again, I thank you for accepting our invitation, sir. So, all the participants, I would request you to stay back. Our session by Dr. Ranganathan Garu will start in 10 minutes. So, I request all the participants to stay back. We'll be back in 10 minutes. Sir, Ranganathan, sir, we will have a session in 10 minutes, sir.
Okay.
So by 10:45 we'll start the session, sir.
Right.
10:50, I think. We are, by 10:50 we'll start the session, sir.
Right.
Okay, sir. Thank you, sir. Thank you so much. I'll also request once again that all the participants to stay back. We'll be right back by 10:50. And session by Dr. Ranganathan Garu will start at 10:50.
Hemlata garu. Hello. Hello.
Sir,
So
Ranganathan sir.
I will try to present my screen. If not possible, then only you do it. Huh?
Okay, sir. Okay, sir. Okay. Sir,
Everything went very well, madam. So once again, welcome back to all the participants. Now let us start our first day session of FDP. I request our today's chief guest, Dr. Ranganadham Garu, to start the session, and the topic
Madam,
which he's going to enlighten us is the path traveled and trends in broadcasting. Sir Ranganathan Garu, I invite you
Madam,
to start the session, sir.
I want to present my screen just.
Okay, sir.
You are doing, no? Now let me do it. If I can't, then probably.
Definitely, sir.
Meanwhile, I'll ask some of the videos to play. You please play. Huh? Yeah, that's why I gave the name.
Definitely, sir. Definitely, sir.
Only the Obama thing only I gave. I didn't give the name. Huh? Otherwise, all other things are named, I think, right?
Okay,
See,
sir.
there are some videos like China.
Yeah.
Yeah, got it. No, when I asked you, please do it because I don't know. I have not linked the PPTs.
Definitely, sir. Definitely, sir.
Now, how to present my screens? The share screen, no? Okay.
Yes, sir. Just press the share screen, sir.
Okay. Is it coming out?
Yes, sir. Yes, we are getting it, sir.
Right.
Right, sir.
So now I'm ready.
Right, sir.
If you are ready, tell me.
Yes, sir. We are ready.
Ready? So it can go up to 12 o'clock, no?
You can continue your session, sir, as long as it takes, sir.
Okay.
You can continue your session, sir.
But hopefully 12, no, right? Up to 12 is okay for you? Or a little beyond?
Yes, yes, sir.
Okay. Good morning to all the participants once again. Today I'm just going to tell you very briefly and without really going into the inside of it, the path traveled so far by the broadcasting industry and what are the trends in broadcasting. Because many of the communications, whatever we are talking about the advancements, more or less 70% is already incorporated in broadcasting. So if when I talk about broadcasting as a specific topic, it also includes many of the common things which we use it for telephone and other industries. So I think it's no. Basically, I want to give you a very general view of the what are the things happened in earlier broadcasting. Now what are the happening now, and what is the future, which may happen. That's what I'm generally very overview. I think that is the right time. I think this is the right time for starting any FDP seminar before going into the nitty-gritty things about all other thing, and that is done by professors. I'm not a professor, so I'm an industry person basically, and it's okay for you. Anybody responding?
Yes, sir.
Okay, thank you. Now we know the earlier. Now, see, we were I think some 20 years back. The only medium was Yagi antenna on the rooftop, where many viewers are forced to watch only Doordarshan. And the good thing is you are all enjoyed. I think the people, that generation, they enjoyed this Ramayana and Mahabharata viewed, and lots of public used to watch those things. It's not that only now with all onset of platforms, different platforms, people are enjoying. Earlier also with single channel from Doordarshan, people also enjoying, and it is very heartening to see some of the senior citizens keep asking us about Doordarshan program still. So the earlier path is a single channel, mostly terrestrial, not even satellite initially, not even cable. So only terrestrial wireless basically was the medium of communication earlier for transmitting TV signal with a single. But now the things have completely changed from a single road to national highway. Now you have innumerable number of channels in the satellite, cable, and even in the terrestrial also. I will come to that, digital terrestrial transmitters using Yagi antennas and all. So there also we are transmitting more than one channel. So things have changed a lot in the broadcasting industry, both in the cable industry and the satellite domain, and of course the wireless terrestrial domain also. Things have moved a lot from single channel to multi channels. Not just multi channels, on a multi platform, in the sense that we are beaming the signals in the mobile, a small mobile screen to very UHD, 57 and 16 inch television sets also with the equally good quality. That is the kind of progress have been made over a period of time in the broadcasting industry. And in fact, as I told in the keynote address, that a lot of advancement in VLSI and embedded systems have contributed to this growth. Just for a brief introduction, we all know about a digital transmitter chains and receptions which is different from the analog, where we will not have source codings and channel codings. We may be having a multiplexer using frequency division multiplexing, and of course a modulator using analog. But I'm not talking about analog now. I'm talking about digital, because nowadays any transmitter, if anybody starts, it will be invariably digital, except some FM transmitters are still there, not only in India, but also in advanced countries. That shows that basically the popularity of the FM transmitters. But otherwise, all other communication systems are in digital format. So I thought it is a very apt to begin with a small diagram of how the digital chain happens. So a lot of advancements are happening in source coding. We were having started with MPEG-2, then we moved to MPEG-4, then a lot of synergy happened between telecom industry and broadcast industry, and that has resulted in H.264, and now H.265 high efficiency video coding are used in some of the streaming services. And multiplexer also, a lot of advancements have taken place. So we are, of course, in digital, we use time division multiplexing. And of course, we don't use much code division multiplexing because of the spectral efficiency. Where spectrum is an important resource, we all know, not only important resource, it's very costly. So we'll be using time division multiplexing. And the important point about the multiplexer is not just alone time division multiplexing. We are using a lot of advancement research is going on statistical multiplexing. That means when I combine many number of channels, for example, in a DTH, any operator these days are giving 300 channels. So that means what? They have to multiplex 300 channels into single multiplexer. And one of the important points about multiplexer is that when I design any DTH for either Tata Sky or Dish TV or the Reliance or Sun Direct, so they'll be taking a fixed, they'll be based on the design parameters, they'll be taking a fixed spectrum from the satellite, which we call it as transponder. So here the important point is, as the content changes, going from a normal news channel to high-end sports program, the data bitrates keeps on varying. Data bitrates keeps on varying because for a news program you don't require a high-end data rate, but for a sports program where the very less redundancy is available in frame to frame, because that's a fast-paced program and you don't get much of the redundancy. So if in order to establish, that means you will be dynamically allocating the whatever data you have across multiple channels ranging from a news channel to high-end programs is a very, very Herculean task, because ultimately you are provided with a constant bitrate. So you have to dynamically change the input content and shoot into the fixed spectrum which we have taken from the satellite. So that is where the statistical, a lot of research is happening in the statistical multiplexing area also. And that is the reason why I'm emphasizing the multiplexer. So you people will be knowing about, okay, TDM and FDMA and TDMA and all. But here the need is from a low-end news channel where we don't really talk about, focus on much of the quality. There the content, what is the news, which is more important. then a high-end football match or a high-end lawn tennis match, where the internal frame, temporal redundancy is very less compared to the spatial redundancy. So where you don't get much of the compression. So, and if you want to give all these programs in a good quality, then you require a statistical multiplexer which dynamically allocates bit rates to all kinds of channels, but at the output, so it will come to the standard bit rate, which is fit for the transponder bandwidth. So that is why the area of research is not only source coding and all compression algorithms, but also multiplexers also. And of course, the channel coding, you all know that today the quality of broadcast reception is increased manifold. You don't hardly see any error in the reception. Even some of the things where small audio jacks will come because of sometimes the bitrate is not good, then only you will find. Otherwise, what we are establishing is 10 to the power minus 8, in the sense that one error in 100 million bits transmitted. Such is the kind of quality in the design parameters all broadcasters are establishing. And the principal reason for this high kind of quality and noisy environment for terrestrial also is that the design of channel coders. You all know that we are using two types of channel coding. One is the convolution, other is Reed-Solomon code. And that means one is good at removing the any random errors, and some are good at removing burst errors where consecutive bits will be, for example, in terms of lightning. So consecutive bytes will be in error. So we'll be using Reed-Solomon code, block codes, and convolution codes in concatenation, so that to arrive at that high efficiency transmission without much of errors. So the broadcast standards currently is 10 to the power minus 8. That means one error can happen in 100 million bits transmitted. So the chief reason for this is the channel coding. And of course, you all know all about modulators. Today, we started with QPSK, which is very good in terms of noise immunity performance. And of course, in terms of spectral efficiency, it gives less than 2. But anyway, and that was to begin with, we started with QPSK. But as the medium becomes better and better in terms of fiber and all, people are also reaching 256 gram. And of course, in terrestrial or satellite, we are still not using beyond 8 PSK. But in terms of cable, fiber cable and all, people are using very good. So this is just an introductory slide where the importance of research in modulator, channel coding, multiplexing, and source coding. That means, all areas of this block diagram, there is intense research is happening. And not to forget that in terms of power amplifier and this role of characteristics, also an important one. In role of characteristics, what I mean is that, see, you can't build a brick wall filter now. So you have to have some rollout, which will go into somebody's other spectrum. So spectrum today is very, very costly. Even the 5G rollout also. Now the base price for India right now going in India is every private operator will say, compared to international spectrum charges. In India, the spectrum charges are very, very high. So here important point is, if the spectrum is very, very important, then obviously you have to have a very zero rise time, zero fall time filters in a power amplifiers and all. So that is also one of the area, how to reduce this roll off. That from, let us say earlier we were using an alpha of 1.35, that means 35% is wasted. So now more and more design characteristics, power amplifiers are coming with 0.2 roll off, and still lesser 0.16 possible. But right now for a transmission of HD quality, we are we are able to achieve 0.2. That means 20% of the things are wasted, because you can't have a zero rise time, zero fall time filters, because that is very costly. So here, in terms of mass media, being a broadcaster, so your TV sets also should be, it should not be costly. So a little bit of roll off is there, so that what is the point of telling is, yes, make it as roll off factor alpha as small as possible. That is also on design. And of course, in antennas, a lot of advancements are happening in antennas, and a lot of planar antennas, smart antennas, and based on the beam lobes and all, switch beams. So this is a very, very broad importance of this. Now, if you look at the theme of this today, your seminar is, one is the communication. Yes, overall is communication. And second is the importance of VLS and embedded systems. If you look at the source coding and all, and the mobiles. So if you look at any mobile, you have FM receiver. Earlier FM receivers, now you have a big set. Now they're all in small chip. So that small chip is embedded in mobile device. So that is the power of the VLSI and the embedded systems. So that's why, again, re-emphasis, the topic is very apt for any communication engineer, because communication without the VLS and embedded systems, it doesn't happen in practice. Any doubts so far? Am I going at right pace? Anyone?
Yes, sir.
Is okay? Am I audible and going in right direction?
Audible.
See, since you're all faculty members and the design issues are very, very key for you, being a communication engineer. So you all know is whenever you design any communication one, see, power is important, the bandwidth is important. Of course, noise is also very, very important, right? You talk about any mobile communication or broadcast communication, any wireless communication, these three are very, very important. So I'll just briefly, even though it's a very, very old system, that I just want to emphasize that all channels are not same. All channels are not same, in the sense that, see, if it is a satellite link, certain things will be slightly different. If it is a terrestrial one, where you're just like your mobile communication, the things are different. If it is a cable, the diagrams will be a little bit different. Your design parameters will be a little bit different in terms of, I told you, power, bandwidth, and noise performance, right? So here in this diagram, you're seeing the three important channels. One is a satellite domain. Of course, what is this DVB? DVB is a digital video broadcasting standard. Earlier, we all know the television, we are using PAL system. And the Americans were using NTSC, and Europe people were using PAL, like that. Okay, you all know about it. Some Japanese systems are using it. So when they migrated to digital, all European people, they have migrated to DVB, digital video broadcasting. And the Americans, they have adopted to other system, NTSC. Okay, so now, see, if it is a satellite, whatever the protocols you are using for the satellite, we are seeing the DVB-S satellite. Whatever protocols standards you are using is for terrestrial, that is DVB-T, and for the cable. So there will be minor modifications. So in the earlier diagram, this is diagram for all. This diagram is, of course, for all generic term. But what kind of channel coding you use for satellite? Say what kind of, how much source coding is required? These are all a little bit different. What kind of model systems you are using? So obviously, if you look at channel coding, it directly depends on the kind of channel. If it is a noisy environment, you have to stuff with more channel coding. So more parity bits have to be added to the system. If the cable is fiber, so obviously less of interference. So you can use a higher order modulation system like that. So you can use a light the channel coding techniques like that. So based on the channel, because you are receiving now through satellite, you are receiving the signals through cable, and sometimes very rarely nowadays these days through terrestrial also. And in fact, in Hyderabad, we already started the digital terrestrial transmitter, in which we are transmitting about 5 television programs and 3 radio channels. In which case, there also you need a small Yagi antenna, because that is in the UHF range. A small Yagi antenna, it's not like VHF where we're using the larger antenna, because you all know with frequency the antenna size reduces, right? So, but the coding may be same, multiplexing is same. You need coding, because anyway data rate is very high, because when you convert from analog to digital, your data rate will be very, very high in terms of, I told you, for a normal conversion from analog to digital, it will result a 5 megahertz original analog signal. In terms of video, it comes to 270 megabits per second. So 270 megabits per second is a very, very high data rate. And audio, fortunately, compared to video, very low data rate. and we are using up to 10 kilohertz data. And if you use about even 16-bit quantization, it is normally around 128 kilobits per second, at best 196 kilobits per second. So in terms of video and audio, the video data rate is requirement is very high. So sometimes we don't use audio always, but video program includes the video, data, and audio, right? If you look at the television screen these days, that more and more TV screens are giving some kind of information. It's not just video and audio alone. It is the data, like for example, scrolling, the other information. So nowadays, the important point is your screen. So they are really looking at more revenue from the data services. So that is why don't underestimate the data part in the video also, unless you watch some movies or something like that. But many of the news channels, if you see, that it is having video, audio, and lots of data on the screen, which is generating a huge revenue for them. So for that, we require, of course, coding. Here it is a MPEG-2. Now MPEG-4 people are using, HDR264. A lot of things are happening. And of course, sometimes you want to encrypt this channel. That you can do scrambling here, multiplexing here. Then, of course, here important point is you must have observed that based on the channel, in cable, I am able to use higher order CAM, which gives me more spectral efficiency, more throughput. I am able to transmit more number of bits in a given bandwidth. But next thing is, when you come to the satellite domain, it is less. It is inferior to terrestrial. It is better than terrestrial, but inferior to cable. So satellite is in between, even though the distance involved between your antenna and the satellite is 36,000 kilometers above the surface of the Earth. But it is less interference is there beyond that the stratosphere region. So only in the lower region you have some interference, man-made noise, vehicular pollution, sparking, all kinds of interference from other frequencies in the UHF and VHF range. But since satellite is in the C-band, in gigahertz range, 6x4, 6 gigahertz in the uplink and 4 gigahertz in the downlink. So at that frequency, the interference is quite less. And of course, beyond that stratosphere, it is an open space where you don't have much of the interference. So the satellite is a little better than the terrestrial in terms of requirement, but inferior to cable, because the fiber optic cable is the best medium as far as the noise performance is concerned. So that is why I'm able to use higher order modulation systems compared to this. For example, you see DVB-C, I'm using higher order modulation systems, and in DVB-S, I'm using quadrature phase shift keying. Also, now people are started using 8PSK. As the systems have evolved with the advancement in VLS and embedded systems, they're able to use better techniques for transmitting through this. But still, the spectrum is an important resource. Transponder cost. The satellite transponder is basically one communication link where we require. So if I got more number of channels, I require more bandwidth. So it all depends on the operator, whether you are using for the DTH. For example, if it is a DTH operator, he is transmitting 300 programs, obviously require more transponders. So if it is an ETV, so they are using around 20. So they require. If it is a Doordarshan, for a regional program, I am transmitting only Telugu program. Whereas for DTH of Doordarshan, we are transmitting around 104 programs. Like that, it depends on your requirement, how many number of programs you are able to multiplex. So that is the reason why here, all this multiplexing are done here. So for any channel operator, if he starts one channel, it will be easy for him to start any other subsidiary channels. So that is why if you see, for example, Gemini serials are there, Gemini music is there, Gemini something is there. So the people, once the digital came into the market, that it's very easy to multiplex different kinds of programs and use a spectrum more efficiently. That is why in many number of channel operators, they are not satisfied with one channel. They are going, once they start one channel, they go for a little more number of channels because they can multiplex that program here and send little more data rate will increase, definitely. But that is definitely optimal if you want to. You will not have the increase, no, only a small increase in the expenditure and because of the spectrum. Other than that, you can use the same facilities for doing it. That's why many of the channel operators are not just one channel. They have many number of channels. And it's very easy to multiplex. So now the satellite. In the terrestrial domain, of course, the most noisy is the terrestrial because the open space is a lot of other the systems are there, communication systems are there, police, wireless, everybody. So their harmonics also will create some problem and all. So then the terrestrial is very, very noisy environment. That is why we are using more rugged channel coding. For example, if here the kind of channel coding I use and here, they're vastly different. So now come to the broadcast areas influenced by influence. See, there the content has to be generated, content has to be delivered to the consumer, and obviously no channel runs with the free. So you have to monetize your programs. So there are tremendous advancements are happening in all three areas. The kind of content is produced these days. Not just, of course, all content is produced now in digital, not in analog. So the kind of cameras they are using from standard definition to high definition to these days ultra high definition and 4K, 8K. So the camera's quality is improving. They are able to capture the image at much higher quality. And the content delivery, still some issues are there because here, delivery we all know. So I told you, the delivery, here a lot of other issues are there, interference issues. So then accordingly, you have to use channel coding, more rugged channel coding techniques and all. So content delivery is an issue that, see, for example, when I'm transmitting a SD signal in a transponder, when I go to HD, the bandwidth will be, in fact, here if I really talk about the 270 megabits per second, when I go for HD, I require 1.4 times, 4 gigabits per second. So it's almost more than 4 times the data rate requirement. So even if you use very high-end encoders, still you require more spectrum for HD. And nowadays, of course, more and more private channels are coming with both SD and HD, even though HD requires higher spectrum. But in terms of quality and all, people are now more used to HD than SD. So now in future, for example, if you look at some of the recent Olympic Games in Japan, so they are now doing in 4K. So that means what? It's almost 2 times the better resolution than HD. So they are now capturing at very, very high resolutions and all. So the content delivery is an important, even though you are producing at high quality, but because of the spectral issues. And of course, if it's a fiber cable, spectrum is not a big issue, important. But when you are really looking at a terrestrial domain, then still some issues are there. And of course, those issues will be to large extent settled by onset of 5G in all this, because 5G is anyway influencing every segment. So broadcasting is no exception. In terms of display devices, there are a huge change. That means, I can't see nowadays. One important point about these delivery is that the same program is watched on mobile with variable display devices to a very high-end plasma and all those kinds of devices with a very different display devices. So here important thing is I cannot transmit the program specific to mobile, specific to catering to different size of screens. So that is why I require some kind of encoding technologies which will adapt to the display device. And that is one of the key areas also happening, doing in the research nowadays. Because see, for me, the broadcast costs I had to reduce. So I will generate once and I will distribute to multiple platforms with a varying bit rates. Obviously, for a mobile, I'll be using a smaller data rates compared to very, very UHD or 8K signals. So I need an encoding device adaptable to the display device. So that is also one of the research areas which are happening in the broadcasting industry. So as I already told, resolution is increasing. So now people, especially advanced countries, they're already having 4K transmission now. So people are also trying 8K in the film production. So, and of course, another important thing is happening is that while you capture the original signal, how real, how closer to the reality, that is also very, very important. And for that, you require the high dynamic range with wide gamut, color gamuts required. The HFR is nothing but frame rate, high frame rate. For example, nowadays, as per the standard, we are using 25 frames per second. Earlier, PALS, now the DVB, digital video broadcasting standard, we use 25 frames, and whereas the American system, they use 30 frames and all. Now, the higher frame rate is important because when you increase the frame rate, obviously the bandwidth will increase, because earlier we are capturing 25 frames per second. Now, for example, if I go for 50 frames per second, then obviously my data will be double, because earlier I'm capturing 25 frames in a second. Now I'm capturing in a double the rate. That means my data rate is increasing. But the advantage of this high frame rate is, for example, you must have seen in cricket matches that when the replays are made, when the replays are done, that even if you miss one frame, especially run-out situations, in a run-out situation, between one frame and other frame, the information is not available. The umpire cannot correlate. So the umpire makes a decision based on what is shown, what is given to him. So if I want more the granular steps for making the right decision, then I have to increase the frame rate. You getting a point? So nowadays, some of the two cameras in a stadium, they'll be using the 100 frames per second cameras only for this replays. Because normally our eye will not be able to observe the high frames, because it all depends on my eye sensitivity. But that is not important there. The criteria is that I should not miss any information. If I don't want to miss any information for making the decision of run out, then I have to increase the number of frames. So there are exclusive cameras are used with a high frame rate, and augmented reality and virtual reality. We will show some examples of that. So we are moving from a linear domain to a disruptive domain. I should not use the word disruptive, because linear domain to a non-linear domain, from a layoff, that means when you watch TV, we generally relax and watch. So no active participation is there in the thing. But nowadays, while using mobile, you can also send the information. In social media also, you can give the feedback. So there is a written channel possible. So from linear domain, people more and more OTT platforms and the broadband, people you have, when you go from a normal SDA route where one person is transmitting and millions of people are watching, and there is no written channel from the customer. But in a nonlinear thing, mobiles, you can also have a written channel, and if you can give a lot of inputs about how you felt about watching the program and all kinds of information is grabbed and used in the other things to make more better and better programs, and for monetization also that will be useful. So people are moving, the broadcasting is moving more and more from linear domain to non-linear domain or additive domain. And in that, of course, one is an IP-based internet protocol. Earlier we are using SDA, means standard definition television, that is used in transport stream. Of course, we are not going into details of that, but now more and more broadcasting is converted into internet protocol, IP, because we will come to that little later on. The people are now using, instead of satellite, people are going for cloud, and artificial intelligence and machine learning is also influencing broadcasting. And of course, it's influencing everything, and broadcasting is no exception to that. And virtual reality we'll see. And the OTT platforms and social media is also another platform. People are projecting their screens, for example, now very popular Jabardast and Extra Jabardast and all. See, they're all more popular in YouTube or streaming devices and other Facebook than a normal. Suppose if you miss it, You can still watch on YouTube and all. So now the broadcasters, now the content is going from very, very slowly from linear to non-linear, and still in India, the linear is dominating compared to the thing, but the shift is happening very fast. So this is what I was focusing on that. So earlier, now we are habituated for one television set, very linear viewing and very relaxed offset viewing, and no active participation except changing the channels and whatever is given, and it's a thing. That is a linear content. Now the non-linear medium is, of course, in any of the mobile devices where you can change the channel and you can go from one stream to other stream. You can go from YouTube to social media and other OTT platforms, Netflix, non-linear. So that now what is the change happening? So the linear content also going to the non-linear devices, and non-linear also shown in the because of smart TVs. Nowadays, everybody is having smart TV. So you can also go for Netflix and other things. The non-linear media is also showing. So the cross things are already happening. So the linear delivery is happening in non-linear also. So that means what you are watching generally. I told you DTT. I'll just in a few minutes I will tell you digital terrestrial transmitter, where you can watch our terrestrial programs. Five Doordarshan programs and 3 radio channels on a mobile also. If you got a proper dongle, if you purchase it, it's free of cost. No bandwidth, no joking, and no buffering, all kinds. That means it's mainly meant for a traditional TV. Now with the digital, you can watch on mobile device also. With a proper, of course, tuner you have to have. See, just like a FM signal, right? Radio signal, I'm listening in a mobile. So that chip is inbuilt in the mobile device. That's why you are able to receive it. Similarly, so that nowadays mobiles are not having inbuilt DTT, digital terrestrial transmitters. So that is why you need an external dongle for receiving it. But I will tell you that the important point at this point of time is the linear TV content, traditional TV, is also now available on mobile live. And similarly, the non-linear media is also available in a television set, because nowadays the television sets are smart. Okay, so now the platforms are different. So there is some kind of convergence is happening. Any doubts so far?
No, sir.
Am I in sync with you?
Yes, sir.
His pace is okay?
Okay, sir.
Thank you. Nowadays, everybody wants quality. For example, nowadays sports events. When I watch any lawn tennis match, so now I invariably prefer HD, right? Because in Wimbledon or French Open and all, or any of the matches, obviously, even if the players Roger Federer or Sharapova or anybody is you're able to see, but the ball is more important, So you need high resolution at that fast pace. So people are going for, and in 4K offers immersive experience. As you go closer to the more high resolution, I'll come to that the gamut issues. As you go for more realistic thing, then it becomes more natural. So when you go for higher resolutions, the grabbing of the original image becomes more real compared to the existing one, right? The number of colors you are using is now restricted. So I will come to that point. So these days, all the channels, what they're doing is, from the last 5 years itself, even though you are now transmitting in standard definition, people are capturing the images in HD and then converting into standard definition, because right now your transmission is based on standard definition because you have bandwidth problems and all. But people are grabbing the content in HD, so that in future, if the transmission network is HD, then same content can be used. Otherwise, there is no point in projecting an SD quality program on a HD screen. you will observe pixelization. And you understand the word pixelization. That means, the quality is not good. You will observe that squares, small squares. So nowadays, all the media, what they are doing is they are using cameras with a 4K and HD. They are cracking the image and converting into low resolution. Then, because this content has an archival value, and that will be transmitted into the later on, can be used later when HD transmission becomes a reality. Of course, HD in satellite mode is already reality. In terrestrial, if it becomes, then the same thing can be used. Okay, I'll come to these parts later on. See, if you look at one of the key things happening when you go for standard definition to high definition, a lot of people think, we are happy with SD. Why we want HD and 4K and all. But once you experience the HD and UHD and 4K, then you observe the difference. For example, now in content production, whatever image you are now seeing, that in the low dynamic range, the number of colors, the gradual grayscaling from black to white, it is not smooth because it has got finite pixels. So you see the low dynamic range, LDR, low dynamic range, to high dynamic range. That means the difference between black and white. So when you depict from black and white, from 0 to 1, you can have infinite number of values to capture the image. Okay. So the low dynamic range, you see from a gradual thing from black to white or white to black. It is not natural. See, natural is your eye is not based on the pixelization. Your eye is based on the continuous thing. So in the human vision is like this, that black to white transition is smooth. But because of the number of pixels are less, and earlier standard definition, you will find the transition from black to white not gradual. Whereas in high dynamic range, the transition from black to white is more natural, and that is why you observe realistic, natural pictures in high dynamic range. And that is the point I'm trying to say. Once you're habituated for ID and 4K, you tend to feel a little resistance to watch standard definition, because even though standard definition is much more higher quality compared to analog signal. So you must, I think our generation earlier, those people who are 50 to 60, we have seen many analog TV sets with lots of noise, and we used to go on a rooftop and adjust the director reflector of Aggie antenna and all. So nowadays those things are now not there. So you have very good quality, and the quality is an evolving one, and ultimate target is it approach human visual system. Your vision system should be, that means you should be able to protect actually what is realistic available in nature, it should be available on the screen. For that to happen, you have to capture better. That's what is basically happening, is not only resolution, but also the dynamic range from black to white, you should be able to depict. I hope you understood the point. So if you look at this, similarly, same thing, especially for the low light areas, in the high light areas, it is quite visible. Earlier, if you see that you are not observing the back of this, that your sky is not visible here. Anybody is, I think, very closely watch. Your this one is not, the background is not visible. Now the next slide, if you take, the sky is visible now, right? That is the quality. It means I am able to capture the original natural image. For that, you require a high dynamic range images. Yeah, this one is based on high dynamic range. I've got all these things. Next one is color gamut, right? Color gamut is, for example, in the HD and UHD, you will represent more natural colors. For example, in HD, then I'm not talking about SD also, standard definition also. I'm talking about HD. HD can only represent these colors within the triangle. It cannot represent all these colors outside the triangle. But for us, HD itself is good. We feel that. But when you go for higher resolution, then more natural things. So these colors also can be, for example, if HD captures around 16 million colors, for example, for 8K and all, it can capture around 1 billion colors. So as you have more and more colors, it approaches the natural image outside available. That's very, very important. So you have advancement in high dynamic range. You are able to capture, your cameras are able to capture more color space so that it approaches more natural to the thing and all. So this is also one chromatic diagram which represents, so far we are thinking HD is the best. No, HD is not representing all colors which your human eye can see. Human eye can see all these colors within the chromacity diagram. But HD is projecting only, your camera is only projecting these images. So it is not natural. So if you want more natural images, especially earlier I've shown that this sky and all. So this image itself you are happy. But when you go for higher quality, that every minute granular representation if you want to make, high resolution, that means more pixels, then in the spatial domain, then more dynamic range, and more wider color gamut. In the sense you have more color representations. That means entire colors where your human eye can see should be transmitted. For that, you require more data. Yeah, you see, this is one beautiful picture having all kinds of colors that normally you see in Holi. So this is also one test diagram for us how qualitative the image is. Now this picture is better because yellow is more yellowish, red is more reddish, like that. So earlier diagram it is not so, because see, the red is not more reddish, yellow is not yellowish completely. So that means as you go for higher quality and all, you are addicted to that things. So in future, what I'm saying is, in future, what is actually happening is you are going from spatial domain resolution, increase from SD to 4K, HD, 4K, and ultra high definition. And secondly, the human visual system you are approaching instead of less number of steps, now more natural transition from black to white happening with high dynamic range. And in terms of colors, you are able to represent more colors, so that is why in future you'll be able to see more natural images on the screen. So trend is towards bigger screens. When you have bigger screens, you have to have data to fill that bigger screen. So naturally, the HD is more suitable for bigger screens and of course high resolution. Now with this fundamental things that are happening in the broadcasting domain in terms of capturing and all, let us come to the terrestrial domain. So what is that we have done? But unfortunately, in Vijayawada we have not started, but in Hyderabad, the last 2 years it is already in operation, which we call it as digital terrestrial transmitter. So now, what is digital terrestrial transmitter? So now, instead of one program, we can transmit. See, for example, one important point is, see, in terrestrial domain, earlier analog transmitters, we are using either VHF or UHF transmitters. VHF range is around 173 megahertz to 230 megahertz. We have a number of some channels. And when you go for UHF, of course, the 460 to 780 and all, UHF transmitters. We have principally two types of transmitter. One is VHF and the other is UHF transmitters. VHF, the bandwidth is 7 megahertz, and UHF, the bandwidth is 8 megahertz. I think many of you must be knowing when you go for higher frequencies why we use the little more instead of 7 megahertz, why you have gone for 8 megahertz. So in that 8 megahertz, earlier we were transmitting, see, because when we introduced DTT, we have introduced only in UHF, because VHF band is very small, and we have large space in UHF, because starting from 460 megahertz to, I think, 868 megahertz. Now some of the UHF is now occupied by mobile operators. But even if 768 and all, where no mobile operators there, mobile operators are already there in 800 range. So we have a very huge UHF spectrum available with us. Earlier, all the analog UHF transmitters were used. Now, people are not watching analog and all, so we want to move to DT, digital domain. So where in the UHF, we have chosen the UHF for better broad spectrum. And there each analog transmitter uses around 8 megahertz. Now the same 8 megahertz, now using digital technologies, we are able to transmit 5 Doordarshan programs in Xment only, and 3 radio programs from radio with the party and all. So the biggest benefit of this DTT is that when you are moving in a car, the very crystal clear programs are, crystal clear images are observed, and no breaks and all, because that is because of coFDM technology. We're using per orthogonal frequency using multiplexing is used, and that's a you all know about it, and multi-carrier modulation systems. Now, which is more rugged for this terrestrial multipath, especially for multipath propagation and all. Because when you are moving at a very high speed, obviously it encounters Doppler shift, and to deal with Doppler shift and multipath propagation, the multi-carrier modulation system is much better. You all know about it. People are already doing research on coFDM, they know it. So all these terrestrial one, we invariably use this modulation system. So thereby we get a very crystal clear thing. So now I request Hamrata Garu. Hamrata Garu,
Sir, sir.
will you able to play 2 videos
Yes, sir. Yes, sir.
for DTT?
Okay, sir.
So what should I do now? I should come out.
Yes, sir.
నేను ఉండొచ్చా ఇలా సేమ్ లో?
ఉండొచ్చు సార్.
Or I can play that video here.
So you can play, or if you want us to play, we can play it, sir.
You play.
You can remain, sir.
You play, and I'll be watching it.
Yes, sir.
Okay, sir.
Rest to me also.
Okay, sir.
DTT in a trails. You just see DTT trails. Not getting played? Any problem? Shall I try to play? I'll just try.
Sir, just a minute, sir.
Madam Garu?
Sir, just a minute, sir. Just
okay. Where is it?
laptop లో చూడండి.
Shall I try?
Sir, 1 minute, sir.
Okay.
Sharing. ఫోల్డర్ ఉంది కదా, పెన్ డ్రైవ్ ఉండాలి కదా.
దాని మీద మీరు రైల్వే తీసుకుంటారు. ఎప్పుడైతే 100% సీలింగ్ అదే ప్రాబ్లం వస్తుంది. ఆ రెండింటిని రిలీజ్ చేయడం బాబు, నేను వింటర్ చేసి నేను మళ్ళీ ఫ్రెష్ తీసుకోవాలని చెప్పేసి వాళ్ళ గురించి ఎక్కువ అడుగుతున్నాను. రిక్వెస్ట్ చేసినా కానీ చెప్పండి సార్, తీసేసుకోమంటారు. తీసేసుకొని మీరు కాబట్టి మా డేటా
ఇచ్చారు.
అవ్వట్లేదా?
Madam, I will play.
Yes, sir. Yes, sir. Here some problem is there.
Okay. Present screen రావాలి మీకు మాకు.
What sir?
షేర్ స్క్రీన్ కి వెళ్ళి నేను ఇంకో కదా.
Yes, sir. Yes, sir.
వస్తుందా? కనపడుతుందా?
అవును సార్.
Just a minute. అది ప్రెజెంట్ చేసినప్పుడు నేను కనపడకూడదు కదా. ఓకే మేడం, హలో
సార్ చెప్పండి సార్.
ఇప్పుడు నేను వీడియోకి వెళ్ళాలంటే ఫస్ట్ షేర్స్కి వెళ్ళాలా?
షేర్ ఆప్షన్కి వెళ్ళండి సార్.
వెళ్తాను. అదే అది ఓపెన్ అయి ఉండాలా, నేను ఓపెన్ చేసుకోవచ్చు తర్వాత?
చేసుకోవచ్చు. షేర్ ఆప్షన్కి
షేర్కి వెళ్ళిన తర్వాత
మీరు ఏ ఫోల్డర్కి వెళ్ళాలంటే వెళ్ళవచ్చు సార్. డెస్క్టాప్ అయినా.
ఓకే, నౌ షేర్ అని సెలెక్ట్ చేసి షేర్ అంట. ఓకే.
yes sir.
Is it coming?
Yes sir. Yes sir. Yes sir, coming sir.
Okay, right?
Yes sir. Yes sir. Yes sir, visible sir.
So it is in a car, it is going at going at around 60-70 plus. You are getting a very crystal clear Doordarshan signal, isn't it?
Yes.
Okay. So again I'll do it. This is what one good advantage is you get 5 channels. You get 5 channels. You have seen the screen. And another one, is coming now? Hello?
Sir, yes sir.
It's visible sir.
Visible sir.
Okay, ma'am. Screen is coming now.
Yes, sir. Yes, sir.
Thank you. Now, what is okay?
PPT is not visible.
PPT is not visible.
Yes. Share screen 12.
Yeah. Now?
Yes, sir.
Okay. So just I have shown you our experiments in a bus and in a car. That means no. The beauty of this digital terrestrial television is it's on mobile. Your TV signal on mobile. That means when not mobile means it can come to the mobile device also. And any screen you can put a TV screen, smart TV in a bus and all. The small antenna, you will receive the signal. That is one experiment done in the city and in a car. That even if you are going at 100 kilometers per hour, and in a radius of, if you have one transmitter, it can get a radius of around 50 kilometers within the cities. And the service has started in 19 cities across India. And it does not need an internet connection. No buffering, because many people already watching on YouTube and all streaming services, but you must have encountered many problems in that streaming and all, right?
Sir, excuse me, sir. Slideshow outlet, sir. Okay, sir. Slideshow.
It's not all.
Slideshow, sir. Just.
Just a minute now. Shall I close and come? Now it is not coming, no? I'll go to the share screen.
Yes, sir.
And
select PPT and slideshow, sir.
That is okay. But yeah, first I'll open it. Then I go short screen. I am in screen share mode only. It is not visible.
No, sir. You have to select that PPT, sir.
Okay.
And then slideshow. You have to press the slideshow.
Now?
No, sir.
Your screen sharing, that message is coming. Okay, stop share. Earlier I got it.
Yes, sir. Now we have to select the share screen, sir. Again. Yes, sir.
Got it, ma'am? Got
No,
it?
sir. No, sir.
Something wrong. No? No.
No, sir.
Shall I use stop video? Then on. No, it's not coming, no? Madam?
Video is
PPT
not
visible,
playing,
sir.
sir. We're not getting it.
PPT.
PPT is, we are getting PPT, sir. You can
You're
see
getting PPT,
PPT,
na?
sir. Yeah, yes, sir.
No?
No, yes, sir, yes, sir.
Yes,
Okay.
Slideshow.
yes, sir.
Okay,
Yes.
sir. Okay, sir.
So, so I will try to finish it because a lot of time is getting wasted on this. Sorry, in the earlier slide, this D65 is for standard definition, and when you go for this one is for HD,
Yes, sir.
and this one. That's it. Next.
Yes, sir. This.
Okay. Now, no bandwidth restrictions. In that 8 megahertz, see, the beauty of this is that in 8 megahertz, I am transmitting all the 5 TV signals and 3 audio. So, and it is not like OTT or any other platform where whenever you watch through mobile while on go. So you basically what is happening? Why sometimes you have buffering and all, because your Wi-Fi connection at that point will not be there, and sometimes the bandwidth issues will come, isn't it? But whereas in that 50-kilometer radius, because of the coFDM technology, you are getting crystal clear picture. I am transmitting, and people are watching. It is actually broadcast. I am broadcasting basically. So whereas in a streamed service, it is point to point, isn't it? So especially the biggest advantage of this digital terrestrial transmitter is when you have a high-end programs like a cricket match. Even though the cricket match is available in, for example, either YouTube or any other streaming media, but as the number of viewers increase, your infrastructure will collapse because everybody is getting from that server only in a normal streamed service. But in broadcast mode, it doesn't depend on how many people are watching. I'm simply transmitting through a terrestrial antenna tower from the tower. Anybody who has got proper receiving system tuner, they'll be able to receive it. For example, earlier in terrestrial domain, so even if one viewer also, same issue. You have multi-million viewers also, same thing, because everybody is getting it. I'm pumping into open air. Anybody has got proper receiving system, he will be able to receive the signal, which is different from the normal streaming service. Streaming service, you always ask for some signal, some video. It will come from that server, and if you have proper permission. Suppose if you subscribe for that, they will give you. And it depends on the number of subscribers, they'll give you. But whenever you have a major events like this kind of program, definitely there will be networking issues. There will be buffering, there will be networking issues. Even somebody who has taken Geo fiber for all these Amazon Prime and all, some point of time you must have observed that buffering. Anybody watched any of these streamed services, and there will be networking issues in broadband, some issues are there, then you have buffering. Anybody agrees with me?
Yes, sir. Yes, sir.
Because you are trying to get the content from the same server where other people also. So it depends on, see, the original server capacity and the bandwidth between you and the server. As more and more people watch the same program, it will be extremely difficult to get the program. Whereas in our DTT, we are in a broadcast mode. It doesn't depend on the number of viewers. I'm broadcasting. You have in your mobile a proper small dongle will be there, which is nothing but a DTT tuner. And nowadays, new sets are also coming up with DTT tuners. And if you have a DTT tuner in your smart TV, you don't require that. But otherwise, in a mobile, right now, Doordarshan is working with Sankhya Labs in Bangalore. to come up with chipset to receive this DTT signal. And very soon, I think this year end, if they come up with a chipset which is part of your mobile, then it will be extremely good. And moreover, since Doordarshan alone is not popular, out of these 5 video channels, if I can get some private operators into this, then that will be definitely a better thing. Because this has an inherent advantage of, what are the advantages? Advantage is, no, it's instantaneous and free from buffering. It does not need any internet connection, because whatever you are getting in a mobile, that is due to data, isn't it? So here in that, no data, no internet, simply you have a tuner and you receive the signal. And it is only battery issue, no bandwidth issue. Batteries obviously depends on your mobile. No, when you continuously watch video, obviously it consumes more battery. So nowadays, of course, you are getting good batteries in the entire 18 hours and 19 hours. So no internet connection, no data cost, no buffering. You are getting good signal. If I can transmit all these things, remove some DD programs, include some private channels, I think that will be a good mix, isn't it? It's extremely entirely free, no data. So that is the thing about this thing about DTT. We can receive on smartphones or any handheld device. We have a small dongle. Right now it's costing around 1,500 rupees. That is USB dongle, the OTG port you should have in the mobile. Mobile handheld device with the DVB T2 chipsets. Technology is convert Wi-Fi model to receive mobiles without using it is also available. That is actually research is going on in Sankhya Labs, Bangalore. TVs nowadays, inbuilt things are also coming. Old TV we can receive using a set-top box. Set-top box is very important for old TVs. This is an example and all. See, that is what we actually have. There is a transmitter is already there. A modulator, amplifier, that transmitter is already there. So now all the DD, National News, Sports, Bharati and all we will receive from the satellite. And local Chandana is of course the Bangalore example I have taken. This is Yadagiri. Yadagiri. I use an encoder and I use those signal and multiplex, because whenever I have more than one, I'll be using multiplexing and then I modulate, amplify and send it to the antenna. This is as simple as any other digital transmitter. Okay. Shall I proceed? Oh, is it okay, sir? Anybody? Hello?
Yes, sir.
So the DVB-T2 mainly it's a free, without internet, no buffering, no bandwidth. It's okay. And not only this one, we are also using some of the wireless equipment to collect information from abroad, and especially our news wing is very active in this. Many of the stringers, they upload in a cloud. That's one thing. If you want a more better quality, if it's a VIP, we send a cameraman, and from the cameraman, even in this camera also, one SD cards will be there, which can store up to 3 hours of content, high quality content. That content, if you want to edit it, you can edit it in a PC. And in that content also can be sent through broadband, or there is other methods through cloud also I can send it. This is how our news wing are using thing. But normally general messages we use cloud only, and the individual strangers at that particular place they will be uploading into cloud. But if some VIP is there, then we will be sending our team. But that team, he can edit. He can. This is a standard SD card, just like a RAM card, and that is a part of this camera. This card you take it and put it in your MCPCA card in any laptop. You download the content, do some editing, and for example, if you want a 5 minutes video, you make it, and then send it through either cloud or any wireless, any broadband media to the Doordarshan Kendra Vijayawada. This is how many of the 80% of the news are covered. That's what here the shooting. Then you can store. There is a drives also there, and then edit it and send it to the news network. We have the live view packs in the sense that in a backpack, the cameramen will put it in the backpack. They have a camera attached to that. Here, what we do is we will be taking 4 or 5 dongles of some mobile operator, because that remote place, all mobile operators may not be active in that place. So we take 4 or 5 or 6 in a bunch, and once the cameraman covers that using this live view package, and this is a very, very good one, very high quality signals will come. If you see this HEVC, high efficiency video coding, where the encoding is very, very extremely good, and which is better than H.264, which is MPEG-4 based. So the latest coding used is, encoders used is based on HEVC. That's where I'm telling you the advancement in VLS and embedded technologies and all. The coders are, encoding has become a very, very high-end small devices. Even in software also it is available. And many of the streaming services use this HEVC. And I think the YouTube, Google, they use VP9 or something, encoding one. So this is how, with advancement in VLSI and embedded technology, we're able to get high quality video signals in through our mobile services, like Airtel or this one, Jio and BSNL kind of things. That's what video rate up to 10 Mbps is extremely good. Even HD signal, high definition signal also can be sent in through a video pack. How it is operating? So live view field unit will have a backpack and camera. The cameraman will shoot it. We have some cellular services. We take some SIMs. All these SIMs as a bonded. So if one SIM doesn't work, it will be used. Software is available, so that the best output will come from this, and through internet it will be sent to the server. Server is available in Doordarshan studio, and that can be given either to broadcast or a streaming service or to mobile. This is how a mobile news gathering unit works. This is the one main thing. We will be having this receiver at our Kendra, and the field unit will have a backpack unit along with the camera. That's it. Through cell phone, whatever the bandwidth we get for depending on the data rates available with those cell phone operators, we'll be taking at least 6 dongles to get a good bandwidth. And since it is based on HEVC, definitely it's double the compression compared to H.264. So obviously 10 Mbps is extremely good. Madam? Hello?
Yes, sir. Yes, sir.
So I'll just skip some of the lot of the things used because of lack of time. So how, see, 5G is influencing every communication system. So obviously broadcasting is also is getting affected. And next year, the Indian government is also rolling out 5G services, and a lot of competition is there between Jio and Bharti Airtel. So even the Jio says we have our own indigenized 5G services, and the government of India said except China, and they can import technology from anywhere. But if Jio does it, it's definitely a good initiative, direction for Atmanirbhar Bharat, because these are all very capital intensive projects. A lot of investment will be there. Networks have to be upgraded. And in fact, 3 to 4 trillion economy is depending on, in few years, 3 to 4 trillion economy is based on 5G services and all. So I think Jio is in the forefront now. And some of the frequencies are also announced. One is in 700 megahertz, other is in 3.3 to 3.6 gigahertz. Other is in 26 gigahertz frequencies are already earmarked for 5G rollout in India. And hopefully by next year, Jio and Bharti, there is a heavy competition. Right now, Jio has the advantage of both the money and the networking. And they have to, of course, upgrade their networking to 5G. So how the broadcasting is going to change with 5G. So there are a lot of examples out there, but I will just simply tell one example of remote production, where any live event happens somewhere else. So earlier, what we used to do is we used to take our truck. We call it as OB vehicle, outside broadcast vehicle. The entire crew, along with the cameras. In fact, OB vehicle is nothing but studio on wheels. So whatever the services we have in the studio, the same services will be there on the entire very big van. So that van has to go to the stadium where the event is happening. All the cables are laid and cameras are laid. Production will happen from there. And from that place, we will uplink to satellite, and satellite downlink again at the concerned stations. They will receive it, and again they will telecast. This is what is going on. With 5G, what will happen is, and 5G and internet protocol, IP based. So right now, it is not IP based, it's a standard definition thing. So now what happens in remote production is that from the stadium itself, only the cameras will be there and cameramen will be there. That's all. All camera outputs will come to the studio through IP connectivity. All this only cameramen will be there in the spot. And because of the 5G, because of the high throughput and low latency and the very good bandwidth, the cameras are IP cameras. The cables are directly laid to the studio. So that network is available. So now this is one remote integration, what we call it as. We can do production remotely. Every enthusiastic young broadcaster, people are interested in that, can be a potential production operator. That means even in colleges, if somebody is interested in making a small jingle or a video or some program, since the availability of cameras is very good, the 5G is coming up with lots of advantages because of you can download at least 20 megabits per second very easily. And I want only 5 GB for good quality video. So the 5G is definitely transforming the broadcast industry. And one example is remote integration, where we will not send any other broadcast vans there. All entire equipment, entire operational personnel, videographs, slow motions, and all will be available in the studio only. So thereby we'll be reducing huge costs of deploying, because we'll be going 2 days before, 3 days before. We have to see the power supply and the connectivity issues and all, and we have to lay the cables and all. Now only cameras will go. If there is an event with 12 cameras to be installed, and 12 cameras will be there, and they're all connected to the studio through IP. And with the 5G services, either 5G services or through IP, it will come to studio. And studio, we have got infrastructure. We have fixed infrastructure that can be used much better than the infrastructure on mobile vans. So this is one. The production cost will reduce by 1/3. So earlier, if 20 lakhs is spent, now it's 1/3. Around 6 lakhs are spent on the remote production with the 5G services. So of course, there are a lot of classes on 5G. I think I can speak. They are the better people to do it. But in broadcasting industries also, and it will also change with the 5G services. Right now, 700 megahertz, 3.5 gigahertz range, and 20 gigahertz are earmarked for spectrum. And already Jio and Bharti Airtel are already competing for this. See, the important point about IP is IP gives you lots of flexibility. So when I want to go, broadcast industry is only 51 billion, whereas telecom industry is 70 billion market. The IT industry is 3,500 billion market. So if you have seen in electronic industry, with more mass consumption, the cost of routers, cost of infrastructure comes down drastically. So now by going to IP, see earlier the biggest problem is I am broadcasting. Okay, the quality is good. The bottleneck for IP is that it is packet based. Okay. So what will happen is it is not direct route. It can take any other route and all. But with the advancement in IP technology, that even the broadcasting also can go live. And many times we have observed. And right now, the seminar is also going IP one, isn't it? It's not a broadcasting thing. So whoever got internet connectivity and they're able to watch. But the professional, the quality if you want to get, obviously, no, you have to have better protocols. Of course, within IP, you have lots of other variables. No, you can do it. You can have a better bandwidth. And once it goes to IP, going from a standard definition to high definition to UHD will be much, much easier. Because I'll tell you a small example. There is a router which is designed for broadcasting will not work for SD router, standard definition router designed for broadcasting SD doesn't work for HD. And HD router which doesn't work for UHD. And this is not the case in IP based. We all know, these IP routers and all, they are coming with because of mass volume in the electronic industry. You all know, So as more and more people watch it, R&D costs will come down, and the manufacturing is anyway with VLSI and advancement in VLSI technology. The manufacturing has become very, very cheap in mass volume because of the market, IT market. In fact, IT means IP market. Internet protocol market is so huge that if the telecom industry and broadcast industry also adopts to IP, then obviously we'll get the advantage of economic scale. So in fact, the broadcast industry, if you go to IP, their cost will come down very drastically. And most of the IP, the services, for example, now OTT services and all, they are going IP way. And that is also one of the reasons why traditional broadcasting is now slowly reducing. That means the satellite domain, the cable domain is slow. The cable domain also based on, they may be giving a signal through cable, but they're receiving the signal through satellite. So the traditional broadcasting pie is now getting very, very slowly reducing, leading to more and more IP-based network. So, and that's a good sign because the electronic industry, more the volumes, economics of scales will get, the cost of production reduce, and that leads to more services. So, broadcast industry is going IP way, and also 5G, and the terrestrial domain going to digital way. This is what I told you, IP-based production. All the studios inside are in our studio. Only the cameramen will be there in the stadium. We have the 5G services here, 5G tower. They are all given to the 5G tower, and it has got a vicinity coverage, and we will receive that signal, and within the studio, we will be able to receive it. It reduces the cost very lot. So there's interactive television and all. I want to skip it. See, I think artificial intelligence, some issues are there, but okay, time is there. The artificial, just a small addition. The artificial intelligence and is also a major influencer on broadcasting, especially in archives. That means earlier, for example, during pandemic, we have a huge archives. That means a program, because Doordarshan is very, very old. We have good content, Ramayana, Mahabharata, those very, very good programs in archives. But getting the indexing was not good at that time. Now locating the content is extremely becoming difficult. See, you have to set hours of content. We have a huge archives base. So we are using for indexing artificial intelligence and machine learning techniques for getting the information fast. So even in artificial intelligence and machine learning is also extensively used in the transcoding, means coding to different formats. And in compressions also, we all know you have to have a delicate balance between the data rate reduction and video quality, right? So if you have a higher data rate, quality also will be good, but the bandwidth is fixed. So how to dynamically allocate based on that? So you have high quality, high bandwidth requirement. So you have to use higher compression ratios to fix it to the fixed bandwidth. So these things are also used AI and ML techniques are used. Okay, and one small example, I'm not able to demonstrate all the videos. Captioning and lip sync. See, nowadays what is happening that majority of the producers, the content is becoming global because of the huge costs of production. Now, if some film is made in Telugu, they are converting into, they are translating into other regional languages like Malayalam and Kannada and Tamil and all, and some big budget films like Bahubali in Hindi and all. So, but in all these, the captioning and lip sync is one of the key areas that see automatically when somebody is thing and captioning has to happen properly. The lip sync is a major issue, and this kind of high resolution content, if this is to be done manually, it takes a huge hours of time, and the artificial intelligence and machine learning is becoming a boon to this. And that is why today people are making very high-end programs and big budget programs. Even international Hollywood movies also converted to Telugu, and that means what? Even the big budget producers are eyeing entire world as their marketplace, because the artificial intelligence and machine learning techniques are used in captioning and lip sync, and it is almost looking real, that as if he's speaking that language. In fact, he's not speaking the language. So the artificial intelligence and machine learning techniques are used in making the lip sync and captioning possible. And of course, you all know about AI learning and neural networking. You have to train it. Data sets are very important. The large data sets are important. You have to train models. Selecting your models are important and all. But the broadcast industry has been benefited by this. And lastly, and I'll just, because they all too lengthy, it has become too lengthy class. See, the last example is now the Tokyo Olympics. What is happening is that extensively the IP broadcasting is used. The 5G techniques are used, and they are transmitting in 4K, not just HD alone. And the countries all, because they have to distribute to more than 80 countries, they are doing in SD, standard definition, they are doing in high definition, they are doing in high definition, and they are doing in 4K also. And in fact, even though, because even in the pandemic also, the government has shown some interest in conducting the games. One key reason is that out of the only satellite rights, television rights, both satellite and IP, they have purchased for $4 billion. See, I repeat, only satellite rights for Tokyo Olympics have been purchased for $4 billion, and which is 70% of the revenue of the satellite. That means, you see how significant this has become, broadcasting has become in IP and other satellite domain, that they have purchased for $4 billion. And if you look at the infrastructure costs of Tokyo Olympics, it is $15 billion for infrastructure. So that is why if they can't conduct it, all this see, major revenues and other models. I'm just talking about broadcasting direction only. So that is why, yeah, broadcasting industry is going in a phenomenal growth direction, and more changes are going to happen from linear domain to non-linear domain. I hope you enjoyed this class. Thank you very much. And if you have got any doubts, you can always mail me. Thank you very much for once again to CRR College for giving me this opportunity. I hope reasonably I have satisfied what I want to deliver. Thank you very much.
Thank you, sir.
Thank you, sir. Thank you so much. Really, really, it is interesting, sir. And of course, we have a time limitation. We seek for much more elaborated presentation, sir. But really, really very useful, sir. And I thank you a lot for again accepting our invitation and your patient presentation, sir. Thank you very much. And
thank you, madam. Any questions if you have? Open to any discussion.
Yeah. Any participants?
Wish to do it. or they can mail me, whatever I
Any
do.
doubts? Yes,
Yeah.
sir.
Yeah.
I think we have seen the mail previously, and also if you want, we'll post it in the group.
Yeah.
So I request all the participants to feel free to express their doubts if they have, or you can contact sir with regarding mail ID. So
Yeah,
in
given the
live,
mail ID. Mail ID, you can always
so
talk to
we
me.
have it. So we have it, sir.
Okay, thank
We'll
you.
post it in the group. Otherwise,
Sure.
or any.
Right.
Right, sir.
Thank you very much, ma'am.
Thank you, sir. Thank you once again. And this is
You have taken the initiative.
end of the session, the first session of first day of.
Thank you, sir. Thank you very much, sir.
Thank you.
Madam, Madam, Grishma, madam. Grishma, madam.
Yes.
Second session will be started to 2 p.m. Please announce.
Second, yes, once again, Ranganathan sir, and I request all the participants to return back at 2 o'clock. So we'll be having the second session in the afternoon, 2 o'clock by Rafi sir. Thank you. Thanks once again. Thank you all.
Sir, close this, sir.